All right, this is just a couple more questions, section 7.1. Using this little A of t formula, we had just did one here where we plugged in the exponent, found the amount, and then we worked backwards to figure out what would be the exponent that would give us the amount that we want, in this case, 650. Okay, I want to do at least a little bit more with this, make sure we're okay. All right, so this is true of cars. So one of the places where exponential functions come into place is with depreciation of vehicles. And most vehicles look like this, where they drop a lot in the beginning and then kind of taper off. And because they drop a lot in the beginning, it's actually pretty smart. I usually buy my cars anywhere between 3 to 5 years because I feel like old, 3 to 5 years old, because they're still pretty good cars and they've dropped almost half their value in the first couple of years. So buying them in here, you can kind of get them at a cheap price, but it's still a pretty good car because it's got a lot of life. So pretty practical example of why exponentials matter. All right, so $10,000 at the start, it depreciates, which is just like a fancy word for decreasing or losing value. We want to find the value after 5 years. Okay, so pause the video, see if you can figure out the setup for this. Okay, and so oftentimes what I'll see here is students, sorry, my computer is freaking out again, will say, okay, we got 5 years, and they do the amount of 10,000, and then they do 1 plus the rate as a decimal. So for 20%, the decimal starts here, and we're going to move it over twice. So it's 0.2, and then the power is 5. Okay, and so the only thing that's different on this one is if I did this right now, I would get something more than 10,000 because I'd be multiplying by 1.2. So the trick is if it is losing money or depreciating or whatever the heck you want to call it, you have to put a subtract in your setup, all right? So that this one really becomes 10,000 times 0.8 raised to the 5th power, right? In that case, we'll be going down because this number is less than 1. So now just type that in your calculator. And you can see that after 5 years, it's lost a lot already, right? We're at $32,077. Not 32,000, 3,200, right? So we've dropped a bunch from 10,000 all the way down to about 3,000 in just 5 quick years. All right, let's do one more. All right, pause the video and give it a shot. All right, so this one's growing. So we've got A is 40,000, and we're going to do 1 plus because we're growing. And then the rate of the decimal, be careful. I see a lot of kids will put like 0.53 here or something, but that's like 53%. So make sure you move it over twice, right? So we're missing a 0 in this one there. So it should be 0.053, and then for, oh, actually it doesn't say how many years, so just t years. So all we got to do is the equation here. So the amount after t years is that, and then you could write this part as 1.053 if you wanted to. But the point is that's the equation. And then if we wanted to find the amount after like 6 years, then we'd put in 6 for t. But if it says just write the equation or model, that's it, right? You just have variables, kind of like you have y and x. That's an equation, right? So here we just have an equation. We don't have a specific value. All right, that's it. Hope this section makes sense, and thank you for watching.